Alright, for number 1 here, you have to find the probability of z being greater than 1.64. So first of all, since you're looking for z being greater than 1.64, you need to look up 1.64 for the z-score in the table. So you go down to 1.6 and over to the 0.04 column. So if you do that, if you go down to 1.6 and over to 0.04 column, you should get 0.9495 from the table there. And then keep in mind once again that if it's greater than, that means it's really to the right of that curve. And if it's to the right, we need to do 1 minus it. Because if you look on your curve, your normal distribution curve there in the table, it shades it to the left instead. So that means that 0.9495 represents the area to the left of the curve. And in this case, we want to the right. So make sure if it's asking to the right that you're subtracting it from 1. And remember, these are not necessarily going to be in this order in terms of which one's greater than, which one's less than. So you do want to make sure you remember which is which, how to know when to subtract and when not to. I like to think of it visually there, that this is to the right, so that means we have to subtract it from 1 to get the area to the right instead of to the left. And those areas really represent probabilities as well. And if you do it correctly there, your area better be, that probability better be between 0 and 1. Otherwise you did something wrong. And then the next one, we're just going a step further here. We have to actually calculate the z-score first. So this is towards the beginning of chapter 5 still. So I try to keep the quizzes a little bit easier. Of course, on the test, you'll have some parts that are a little bit more challenging. But here we have z equals, remember you do your value. So in this case, we're looking for x being less than 60. So 60 is your value. And then minus the mean divided by the standard deviation. And value minus the mean divided by standard deviation. So here then we get -5 divided by 7. Make sure you do that subtraction part first and then divide. Otherwise, you're going to have to put parentheses around the numerator, around that top number, in order for it to calculate it correctly. Otherwise, it's going to automatically do the division before the subtraction in your calculator. So then here you get approximately -0.71 if you round to 2 decimal places, because remember in the normal distribution table, you can only go at 2 places for your z-scores to look those up. Remember, you should be rounding these correctly. If that number after the 1 was 5 or more instead, then you would have wanted to round the 1 up to 2. But in this case, the number after the 1 was a 4, which means we keep the 1 the same. So make sure you do round those correctly as well to get the correct answer. So then, once again, if we go to the negative part and we go down to -0.7 and over to the 0.01 column, here you should get 0.2389. And then in this case, we're dealing with less than in this case, because it said x was less than 60, which means to the left of the curve. So we don't have to subtract it from 1 in this case, because it was a less than. And that's what's already given to us in our normal distribution table. So make sure you can remember when to subtract it from 1 and when not to, and also how to calculate your z-scores there. For number 3 here, you're dealing with the percentile. So this was the one whenever you had to look in the area part for whatever's closest to 0.70. So you want to look to see in the chart, in the area part, in the center part there, for whatever's closest to 0.70. So if you're looking in that, so once again, you're looking in the center part, so not at the z-scores yet. You're looking in the center. One of those looks like one of them that's closest is a point 6985. So we can subtract each of these that are closest from 0.70. If you're not sure which one's closest, you can subtract it here to see which one's closest. The other one looks like was 0.7019. So here we'd get 0.0015 away from the 0.7. And then the other one here, again, negative 0.0019. So that means this one's closer because it's closer to 0. So we want whichever one's closest to 0. That's the one that's closest to our 0.7. And just like in the hallmark, if they're both exactly the same distance away, then you want to make sure that you're averaging those two z-scores, adding them together and dividing by 2 if they're exactly the same distance away. But in this case, we had one that was closest. It was this area of 0.6985. So then you have to look to see in the table what z-score that corresponds to. So you have to go over to the left and then go up to see what that z-score is. So in this case, your z-score, so your z here, ends up being 0.52. That's where I've been telling a lot of you, you need to make sure you're labeling this stuff so you remember which ones are your z-scores and which ones are your probabilities or areas, so that way you don't keep getting those mixed up. So here in this case, the area that was closest was 0.6985, and then that corresponding z-score for that value was 0.52. So your 0.52 is your answer for your z-score there. And those were going backwards here, what we had to do in the first two problems. And then the last one here, I don't need you to actually calculate the probability. All I need you to do is just write it out with the continuity correction. So that's similar to some of them at the beginning of section 5.5, whenever you're doing that stuff where you just had to adjust it. You're not actually calculating a probability here. So remember, one way to go about figuring out how to adjust it up or down by that 0.5 is to use a number line. You don't have to do the number line, it's just one way to kind of show some work there of what you're thinking. This one, it was less than or equal to 35, so we're including the 35 in everything that was less than it. So for the continuity correction, to approximate it with that normal curve, we would have to go up just a little bit more. So we're including a little bit more than what we already had to try and help fill in that gap there that we had with the binomial distribution, because the binomials had whole numbers, it didn't have any decimals. So here then for your answer, you can keep the same inequality sign, you're just changing your value there. So you'd have it as 35.5 instead there. Like normal, if you have questions on any of this stuff, certainly ask before the quiz.